I would like to show you how to perform a trigonometry problem of vectors. And let's go ahead and read the problem. A ship travels 30 knots from its home port on a course of 97 degrees for 2 hours and then changes course to 187 degrees for 2 hours. Find the distance and bearing of the home port to the ship. Okay, so we're looking for displacement 3 and theta 3. That is the length of this resultant vector and this angle with reference to straight east. Let's assume straight east is the positive x direction, straight north is the positive y direction, and we can draw a picture that leg 1 of the trip is distance 1 vector displacement, and then displacement 2 is at the second angle. Now notice, if 30 knots is the velocity, let's assume that to be constant, that's 30 nautical miles per hour, and that's the constant velocity. If you times that by the time of 2 hours, you get 60 nautical miles, and that's the length of each of these vectors, because let's assume the ship does not change its speed. Remember, we're rotating with respect to the positive x direction, so let's assume that's the 0 degree measure. I'm assuming that's what these angles are with reference to. I've also seen 0 degrees is straight positive north, and that east is 90 degrees, south is 180 degrees, 270 degrees is west. So you get the same answer as we've got here, but just sort of in different quadrants. Now notice each of these red and blue vectors form right triangles, and what we should do is we should use these angles and get the x and y components. So we should find the x and y components using cosine and sine of the respective angles, add the components along each axis, use the Pythagorean theorem to get the total resultant magnitude here, and then we should use arctan of the ratio of the y component over the x component. And we have to think about these angles carefully. Now notice, in order to do this, we'll define this angle right here as alpha 1, and then this angle right here as alpha 2, knowing that really this entire angle right here was actually theta 2, okay? So let's go on to the next board and let's work that out. So notice I have displacement 1 and displacement 2 vectors, but I have them broken up into their x and y components. Notice that theta 1 was 97 degrees, so that's 83 degrees short of 180, so alpha 1 turns out to be 83 degrees. Likewise, alpha 2 turns out to be 7 degrees because 187 degrees in comparison to west, that's the negative x direction, is 7 degrees larger than that. Notice the x components are both negative because each time we're going to the left, to the west, and notice the y component is positive for displacement 1, but it's negative for displacement 2. So you should work out the displacement is 60 nautical miles in each case, but then you should do cosine and sine for x and y components, negatives for displacement 2, negative for x and positive for y, and we should get these values. Notice that these values are actually just, sort of switching x and y, and that's because of how the triangles are oriented. So notice the resultant x component should be the x component of 1 plus the x component of 2, and the resulting y component should be the y component of the first one plus the y component of the second one. Add those up as positives and negatives. You get negative 66.9 nautical miles and 52.3 nautical miles, negative positive. To get the resulting magnitude, you should take the x component squared plus the y component squared, then take the square root. That's using the Pythagorean theorem. That gives us an answer of 84.9 nautical miles. Notice that's going to be the length of this resultant vector right here. And then finally, the final angle, alpha 3, will be given by the inverse tan of displacement in the y direction over displacement in the x direction of the resultant vector. When you work that out, you get negative 38 degrees, but we know it's in quadrant 2, so that's positive 38 degrees. We subtract that from 180 degrees, that's 142 degrees. Hope that was helpful. Hope you understand the problem now. Thank you for watching High Peak Education. Please smash that like button if you enjoy this content. Please Share this amongst your social networks to have additional views and to grow the channel. Please subscribe, and I look forward to reading your comments, and I look forward to seeing you in the next video.